Here we are solving Pure Math 4 May-June 2024 paper. In part 1 of the video we have completed question number 1 to 3. Let's look at question number 4. Figure 1 shows sketch of a segment PQRP. This is PQRP, this segment of a circle with center O, radius 5, center O. The angle POR is theta radians. Theta is increasing from 0 to pi at a constant rate. So you should be able to change this into a mathematical expression. If theta is changing, d theta by dt is 0.1. The area of the segment is A. The area of the segment. How do we find the area of the segment? We take the whole area of the sector, which is half r square theta minus the area of this triangle, which is half AB sine theta. AB are both are radius, so 5 square sine theta. That's the area of the segment, the shaded one. Now show the dA by d theta is this. Okay, we just calculated A, which is half times 5 square times theta. Half r square theta is the area of the sector minus area of the triangle, half r square sine theta. You can take half 5 square, which is 25 by 2, as a common factor. You will have theta minus sine theta. Differentiate it with respect to theta. You get the answer already. 25 over 2, 1 minus theta. Derivative of theta is 1. Derivative of sine theta is cos theta. That's all. Just a 2-mark question. Let's move on to part B. Find in centimeter square per second the rate of increase of area when theta is this. You need to use this formula, dA by dt, whenever they say the area, rate of increase of area. A is a function in terms of theta, so you can write it as dA by d theta times d theta over dt. dA by d theta we just calculated here, 25 over 2, 1 minus cos theta times d theta by dt is given in the question as 0.1. So times 0.1. Now you need to find this value when theta is pi over 3. So dA over dt when theta is equal to pi over 3 is 25 over 2, 1 minus cos pi over 3 times 0.1. We just need to calculate this. So I'm going to use my calculator in radian mode. 25 over 2. First let's put everything in one shot. If we get a decimal number, we will change it. 1 minus cos pi over 3 times 0.1. Okay, we got 5 over 8. So the answer is 5 over 8 centimeter square per second. Sometime when you type everything in your calculator, you will get a decimal number. In that case, don't write the decimal number. You need to do it separately. Find the value of 1 minus cos pi over 3 and do it manually. So you will get the exact value like this. That's all. Question number 5 now. We have a diagram given. There is a curve and a line. They put 1 here. So this line is y is equal to 1. And there is another variable t. Let's read the question. The parametric equations are given from A to B. The ends of the curve lie on the line y is equal to 1, as you can see from here. Right? They put t is equal to a at this point. At this point t is equal to b. They want you to find the value of a and b. So we take this, replace y by 1, because the equation of the line is y is equal to 1. So 1 is equal to 2 over t times 3 minus t. So put the denominator here. 3t minus t square is equal to 2 you'll get t square minus 3t plus 2 is 0, which is t minus 1 times t minus 2 is 0. T is equal to 1, comma, t is equal to 2. So you can say a is 1, b is 2, because that's the limit. The smaller number will be a, bigger number will be b. That's just an easy 2-mark question. Now part B. The region R shown shaded in figure is bounded by the curve and the line. As you can see here, this region is bounded by the curve and the line. This line is y is equal to 1. Show that the area is given by this formula, m minus k. Okay, think about it. How can you find this area, the shaded area? Since you know the curve parametric equations of the curve, if you integrate the curve from A to B, you will get this area, the area below the curve. And if you can find the whole area of this triangle, you can minus them. How do we find the area of the triangle? The height is 1. How about this distance? What you're not supposed to do, you know the values of A and B. So don't think that 2 minus 1, this length is 1. That's wrong. Because those values of A and B are not x coordinate, are not the values of x. They are the value of t, the third variable. So you cannot simply subtract them and find the length of this line from here to here. You need to find the x coordinates corresponding to these t values. So you need to use the first equation, t square plus 2t, x is equal to t square plus 2t. So when t is equal to 1, x is 1 square plus 2, 3. When t is equal to 2, x is 2 square plus 2, 4. 4 plus 4, 8. So what does that mean? Here the x coordinate of this point is 3. That's 3 here. 8 is the x coordinate of this point. So the length is 8 minus 3, 5. So you can find the area of this triangle, which is breadth times width, 3. That's just 5. 8 minus 3 is 5. So the area of the triangle is 5. Area of the triangle is 5. Now we need to find the area below the curve by using the integration. So back in here, so we can write the area as 5 minus, that's why they put m minus, m is 5. Integral the values of t, 1 to 2. The formula to find the area is integral y of t x dash of t dt when you have parametric equations. So you need to take y as it is, 2 over t times 3 minus t times. You have to differentiate x, differentiate this, you'll get 2t plus 1, 2t plus 2 actually, 2t plus 2 dt. So if you take 2 as a common factor and multiply with this, you will get 5 minus 4 integral 1 to 2 t plus 1 divided by t minus 3 minus t dt. This looks exactly like this, where m is equal to 5, k is equal to 4. That's all. Part C says write this as partial fraction. You have t plus 1 over t minus 3 minus t. The degree of the numerator is 1. The degree of the denominator, when you open the bracket, you will get t square. So 1 over 2 is a proper fraction. You need to check that first. For proper fraction, you can write it as a over t plus b over 3 minus t. Multiply throughout by denominator, you will get t plus 1 is a times 3 minus t, b times t. It's easy to find a and b here. Replace t by 3 first. This becomes 0. You will get 4 is equal to 3b. b is 4 over 3. and then replace t by 0. This becomes 0, this is 0, 0. You'll get 1 is equal to 3a, so a is 1 over 3. So finally you need to write this step at the end if you don't want to lose more. T plus 1 divided by t times 3 minus t is equal to a over t. A is this, so put it this way, a over t, put the denominator together with t, plus b over 3 minus t, 4 over 3 times 3 minus t. That's it. Now use algebraic integration to find the area R. You see, to find the area R, we have to integrate this section. To integrate this, you need to apply partial fraction method. So you can write area is equal to 5 minus 4 integral 1 to 2. Apply the partial fraction we have just calculated. So 1 over 3t plus 4 over 3 times 3 minus t dt. And then carefully integrate it and sub in the upper limit, lower limit. So it's going to be 5 minus 4. I'm going to integrate it. Keep 1 over 3 as it is. Integral of 1 over t is ln t. You don't need to put a modulus because both these numbers are positive anyway. You won't get ln negative number. Sorry. Okay. Minus 4 times. Plus 4 over 3. This becomes ln 3 minus t divided by the coefficient of t. That's all. So what I'm going to do, I'm going to take 1 over 3 as a common factor out. So 5 minus 4 over 3, you will have 1 over 3 ln t minus 4 ln 3 minus t. Now sub in the limits. You see how I am subbing in the limit actually. First replace t by 2. When you replace t by 2 here and here, the first one is 1 over 3 ln 2 minus, here when you sub in, 3 minus 2 is 1, ln 1 is 0. So it's straight away 0. Minus, when you sub in lower limit here, ln 1 is 0, minus 4, when you sub in here, you will get ln 2. Simplify it, you will get 5 minus 4 over 3 times 1 over 3 ln 2 minus into minus plus 4 ln 2. Let's read the question whether they want the answer in a particular format. They say give your answer in simplest form, that's all. So let's try to simplify it further by taking ln 2 as a common factor. Or 1 over 3 plus 4 is basically 13 over 3. I think there shouldn't be 1 over 3 here. If you look at the previous step, we started from here and we have taken 1 over 3 as a common factor out. Sorry, I messed it up. So there shouldn't be any 1 over 3 here, because we have taken 1 over 3 as a common factor out, right? So it should be just ln 2, that's all. So it's ln 2 plus 4 ln 2 is 5 ln 2. 5 minus 4 times 5 ln 2 is 20 ln 2 divided by 3. That's the area. That's all. It's a 6-mark question. Question number 6 now. With respect to a fixed origin O, the line L1 is given by this equation. A lies on L1 and the modulus of OA is given as, the magnitude of the vector OA is given 5 square root of 10. Show that at A the lambda satisfies this. From this equation you can straight away write the OA vector in this form: 1, 2, 5 plus lambda times 8 minus 1, 4. So in fact you can write it as, you can combine them, 1 plus 8 lambda, 2 minus lambda, 5 plus 4 lambda. That's the position vector of A. If you know the value of lambda, you can sub in here to find the actual position vector. This is a position vector in terms of lambda. Using this position vector, if you find the modulus of OA equated to 5 root 10, you will get this equation. So how do we find the modulus of the highlighted vector? Square root of x square plus y square plus z square, right? So x square, 1 plus 8 lambda square plus y square plus z square, sorry, 4 plus 5 plus 4 lambda square, square root of everything. That's how we find the magnitude of the vector, right? Which is equal to 5 square root of 10. Square both sides, open the bracket and simplify, you will get this equation. So when you square both sides, this becomes, and open the bracket, a square plus 2ab plus b square, a square minus 2ab plus b square, a square plus 2ab, 5 4s are 20, 40 lambda plus b square. I have opened all the bracket, is equal to, square this also, because we are removing square root on the left hand side. So 5 square is 25, square root of 10 whole square is 10, so you will get 250. Put everything one side and simplify the like terms. So you see, I'm going to simplify the like terms here. Let's look at lambda square. You have 1, oh sorry, here this should be 64 lambda square, right? 1 plus 64 is 65, plus 16 is 81 lambda square. We got the first term already. And then lambda, 16 minus 4 is 12, plus 40 is 52 lambda. We got the second term also. And then the constant term, 1 plus 4, 5 plus 25 is 30. When you bring this here, it becomes minus 220. So minus 220 is equal to 0. That's it. We got the answer already. Let's move on to part B now. Hence show that one possible position vector of A is this, and find the other possible position. You will get two possible position vector of A. When you, why, you know, because when you solve this quadratic, you will get two values of lambda, and then when you sub in the values here, you will get two possible positions, position vector for A. So how do we solve it? I'm going to straight away use my calculator to solve it. Go to number 5, equation number 3, 81, 52 minus 220. You get 110 over 81. So lambda is 110 over 81, and then minus 2. But whenever it comes to solving quadratic, you need to write one more step here. So write them as factors. 81 lambda minus 110 lambda plus 2 is equal to 0. That's it. We got two values. They want us to show that one of the position vector is this. We know the position vector of OA is equal to this one, 1 plus 8 lambda, 1 plus 8 lambda, 2 minus lambda, 5 plus 4 lambda, 5 plus 4 lambda. The values of lambda are 110 over 81 and minus 2. So to get this, you need to sub in minus 2. So when you sub in lambda is minus 2, you will get OA is equal to 1 plus 8 times minus 2, 2 minus of minus 2, 5 plus 4 times minus 2. So you will get minus 15, 4 minus 3. Therefore OA is equal to write it in this form. This is what they want, right? And then to find the other position vector, replace lambda by this value now. Here replace lambda by 110 over 81. 110 over 81. 110 over 81 and calculate this. 1 plus 8 times 110 over 81. 961 over 81. 961 over 81. That's the first value. 2 minus 2 minus this. 52 over 81. 52 over 81. 5 plus 4 times 5 plus 4 times this. 845 over 81. Write them as vectors. That would be the other possible position vector. This is a vector actually. You can just leave it like this. Let's look at part C. I'm going to draw a diagram to understand this. It says L2 is parallel to L1 and passes through the origin O. So let's draw L2 here and L1 here. Take the origin somewhere here. Let's say this is O. Now OA is given this. We have found in the previous part there are two possible positions of OA and they are taking this particular OA. You see, think about it. The A can be in two places, here and here, on both sides of O. You might be thinking, why not A1 can be here, right? It's not possible because in the previous sum it's given the OA is 5 root 10. So instead of in order for this length to be same, it has to be an isosceles triangle. So A1, A2, the two possible positions of the vector A should be on both sides of O, right? So we have A1 and A2. Now there is another point B lies on L2. With this OB, the length is given. So the B can be here or here. We don't know where the B is. It doesn't matter. To find the area of the triangle, what are we gonna do? Let's assume B is here. We need to find the area of OAB. You can take either one of the point. I'm gonna consider this as base. The height is the perpendicular distance from the third vertex to the base. So this should be the midpoint of A1 and A2. So what I'm gonna do, I'm gonna find the midpoint of A1 and A2 and find the length OM. We are already given OB vector. You can use the vector to half base times height. You will get the area. That's one of the easiest way to find the area. So I'm gonna find the midpoint of A1 and A2 first. We have one of the position vector of A here we calculated in the previous part. I'm gonna use this and this one also to find the midpoint now. So you can write, let M be the midpoint of both A's. So OM vector is equal to, you need to add these two, divide by 2 to find the midpoint. So it's going to be 961 over 81 minus 15. You need to divide everything by 2. 52 over 81 plus 4. 845 by 81 minus 3. So I'm going to calculate this now. Okay, first 961 over 81 minus 15 divided by 2. minus 127, minus 127 by 81, minus 127 over 81. And the second one, 52 over 81 plus 4 divided by 2, 188 over 81, 188 over 81. And the next one is 845 over 81 minus 3 divided by 2 is 301 over 81. That's the midpoint, position vector of the midpoint. To find the length of OM, we are going to find the modulus of OM now. OM vector is equal to modulus of this vector. So it's going to be square root of, let me try to put everything in the calculator and see what's happening. Square root of 1, all the bases of bases are 81, so let's forget about 81. 127 square, 188 square, 301 square, okay, and then divided by the 81. Square and square root, you will get 81, whatever the value you have here, which is divided by 81. You get 4 point modulus OM vector is equal to 4.653, etc., etc. I'm gonna immediately store the value as A. Store it as A. So back to the figure, we got the length OM already, that's the height, and we know OB vector, which is given here, 4 root of 10. So the area is going to be half base times the height we just calculated. So it's going to be half times 4 root of 10 times A. 29.43, etc. They want you to round it to one decimal place, so the answer is going to be 29.4 square units. That's all.